Welcome back, kids. So in the initial video, right, I explained you all the formulas related to exponents and indices. Now let's look at some examples. How to tackle these problems using those formulas. You're not going to do anything different, but to use those formulas to basically solve these problems. I've just taken 3 problems over here to make you understand how to use those formulas and solve them simply without complicating and putting proper steps. Okay, let's start with the first one. If you look at it, there are two algebraic terms which are a product. They are asking to find the product of those two. So what I'm going to do first thing, you're going to expand the stuff. So first things, you have coefficients over here. You're going to write those coefficients together. Done. This is taken care of. This is taken care of. Now look at it. You have x to the power 4 and I have x to the power 3 over here. I'm going to write it together. Then I have y to the power 3 times y to the power 5. Now we know, right? Now this I know 3 into 18 is 54, right? Times you have two terms of x over here, x to the power 4 and x to the power 3. What are you going to do? Can I use the first rule, x to the power 4 plus 3, right? Always put it in a bracket over there so that you don't get confused in your problems. Now you have two times of two bases of y over here. Can I put it like this? 3 plus 5. Look at it, how easily I could simplify. So you have something called 54 times x to the power 7 times y to the power 8. So your answer final, you put it all together, this is your answer. Make sense? Easy? Okay, so let's move to the next one. What does the next one say? It is a division problem over here. There is a numerator which is divided by this particular denominator. What I'm going to do? I'm going to do the same thing over here. I'm going to put 3 by 18, separate it out. I'll put a dot instead of multiply. So a dot signifies a multiplication. So I'm going to put x to the power 4 divided by x to the power 3. I'm going to basically, what I'm trying to do is that I'm logically putting them together so that I can use the formulas. Okay, now you have y to the power 3 divided by y to the power 5. So what happens? 3 ones are 3, 3 6s are 18. So the coefficients are solved. You get 1 by 6 over here. Now can I use the rule? Which one? The rule which we have learned, x to the power 4 minus 3. Between these two, similarly, what I can do, I can put it as, either I'll put it as 3 minus 5 over here, or there is other way to put it as that. How can you? I can put it in the denominator also. I can use the same formula as denominator. I'll put it as 1 by 5 minus 3. I can do the same thing because what I'm trying to do is that I'm bringing this 3 down over here to use that particular formula. So what do I get? In the numerator, I get only x because x into 1 gives me x, and in the denominator, I get the 6 times y to the power 2. So my final answer is x by 6y square. Simple? Simple? Do it simply. Okay? Now the third one. Let us look at the third one. Whenever you have an exponent outside a bracket, means that exponent will be applied to everything which is there in the bracket. Remember that one. Never miss out this one. Most of the kids, I see that what they do a mistake is that they only apply the exponent to the variables and not to the constant. You have a constant over here, you need to apply to that as well. So simply what am I going to do? I'm going to write it like this. It is minus 2 to the power 3 because this 3 applies to minus 2. Similarly, this x to the power 2 is there inside the bracket. I'll apply 3 for power there also. And I have y cube. I'm going to put y cube whole to the power 3. Now look at it. Does it look simple? Now what can I do? Minus 2 to the power 3. Can I write it like this? 3 times dot. What is this one? We learned that formula. Anything to the power m to the power n, whole to the power n becomes what? X to the power 2 times 3, right? Do you recall that formula? And similarly, in the denominator, you have a 3 inside and you have a 3 outside. So you multiply both of them there. Now look at it. Minus 2 into minus 2 will give you plus 4. Plus 4 into minus 2 will give you minus 8. Remember, you have to basically do it one by one so that you don't miss out on that minus sign. If you miss out a minus sign over here, you'll get the entire problem wrong. And this becomes x to the power 6 and this becomes y to the power 9. That's your answer. Because you cannot simplify it further. Everything is a different, if you look at it, x and y, you won't be able to use any formula because the bases are different. If there would have been a case where x and y had the same exponent, then you would have used that formula where we had discussed about same exponent but different bases. Okay, got it? Make sense? Let's move on. Okay, let's look at another example. The moment you see this particular question, aren't you confused? There are a lot of numbers, there are a lot of square roots, there are a lot of fourth root, third root, fifth root and all. Let's see how we can tackle it simply. Basically what we need to do is that first and foremost thing in any problem, what you need to do is that you need to remove the noise. There is a lot of noise in these terms over here. Let's simplify it to understand it better and then do it. So the first and foremost thing what you need to understand is that between the operators, these are all terms. These are all single terms if you look at it. When I say operators, between these minus, plus and all, if you look at it, you have a 8 times cube root of 216. So you need to write the problem properly. You cannot write that 3 over here, otherwise it will read as 8 times 3 times square root of 216. Don't make that mistake. So when you're writing it properly, whenever you're writing the root over here, it needs to be a smaller number. Don't write it very big. Okay. So similarly, this is 15 times fifth root of 32. And this is 2 times square root of 25. I hope that makes sense. Okay. At least you are able to understand what the problem is. Now, the first and foremost thing what you need to do in these kind of problem is that get rid of this sign. Get rid of this particular sign so that your life becomes much more easier. So first things first. Now if I have to get rid of this sign over here for a fourth root of 81, how am I going to write it? I'm going to write it as 81 to the power 1 by 4. Done? Sorted? Okay. Next one. I'm going to put a bracket because it has 8. It has a 8 times cube root of only 216. So you need to put it like this. 216 ka 1 by 3 only. This 1 by 3 doesn't apply to 8, remember, because 8 is outside. Remember that one very well. When you put it in brackets clearly like this, the way you guys have learned BODMAS problems, you remember, if you put brackets, it becomes very simple to solve. Okay, now go to the third term. What do I have a third term? I have a 15 outside. I'm going to put 15 over here. Dot, I have a fifth root of 32. So I'm going to write it like this. 32 to the power 1 by 5. Okay, right? Okay. Let me rub this. Okay, and I'm left with this particular term. What does this particular term signify? It is nothing but, again, it is 2 times 225 to the power half. Because I don't have any number over here, so it's a simple square root. Whenever there is a number specified over here, the root, that will be the root of that one. If there is a 5 over here, that becomes 1/5. If there is a 3 over here, that becomes 1 by 3. And if there is a 4 over here, that becomes 1 by 4. Okay, now you have simplified it and you removed all the root symbols from the problem. Now let's go to the next step. First and foremost thing. Now if you look at 81, what you need to do with this 81 is that go ahead and find the factors. How do I find the factors? I use that ladder method to get the factors. I'll start with 3. Okay, 3 27s are. 3 9s are, 3 3s are, 3 1s are. So how many did I get? I got 3 to the power 4 3 into 3 into 3 into 3 gives me 81. What does that mean? That means that this is nothing but I can write 81 as 3 to the power 4. Right? Good. Let's replace that one with 3 to the power 4. So this becomes, this 81, I'll write it as 3 to the power 4 inside and whole to the power 1 by 4 outside. Sorted? Now similarly 216. What can I do with 216? Again I'm going to find the factors. So I'll do it with 2 because it's an even number. 2 tens are, 2 eights are, 2 fives are, 2 fours are, 2 27 and 3 nines are, 3 threes are, 3 ones are. So what did I get? What did I get? 216, I can write it as 2 to the power 3 into 3 to the power 3. So you remember that formula where we have learned when the bases are different and the exponents are same. Can I write it like this? 2 into 3 to the power whole to the power 3, which is nothing but 6 to the power 3. Right? So your 216 is nothing but 6 cube. Okay, I'll replace that now. I'll go back and replace it. Right? So now I put this one, I put a square bracket, 8 is outside, I leave it like this, and inside this 216 I'm putting at 6 cube, and outside I have 1 by 3, close this. Now I go to the next term, right? Similarly, I have a 32 over here. Find the factors of 32. 2 16s are, 2 8s are, 2 4s are 8, 2 2s are 4, 2 1s are 2. How many 2s did you get? 32 can be written as 2 to the power 5. If you see 1, 2, 3, 4, 5, right? Make sense? So I'm going to replace 32 by 2 to the power 5. So now similarly I need to write this 15, which is outside, times 32 will be replaced by 2 to the power 5 whole to the power 1 by 5. Right? Close the bracket. Now I come back here. Now again I start this 2. I'm going to write it the same as is. Now look at 225. Again find the factors of 225. How do you do it? 5 45s are, 5 9s are, 3 3s are, 3 1s are. So what do you get? 225 can be written as how? 5 square, because you have 2 5s, right? Into 3 square. Again that rule you can apply. The bases are different but your exponent are same. So can I write it like this? 5 into 3 whole to the power 2, which is nothing but, it can be written as 15 to the power 2. So 225 is nothing but it is 15 square. 15 into 15 gives you 225. You might be knowing by now all these things. So I'm just doing it in a simplified way so that it becomes easy to understand. 225, I'm replacing it with 15 square and to the power half. Sorted? Now if you look at in all the expressions, what do you have? You have this rule. Can you apply this rule in all the cases? Look at it here. Okay, so let's do this. What is the power inside? Your base is 3, your n is 4, into n is 1 by 4. I did that. Minus, similarly here, 8 times 6, 3 to the power 3 into 1 by 3, which is there outside, right? So always what you do is that put these in brackets so that you don't get confused, right? This is the easiest way to do things. Now next one, 15 times I have 2 to the power 5 into 1 by 5. Done? This is done, sorted. Next one, again 2 to the power 15, you have a 2 inside and half outside, so put them together. So now look at it, what happens? Everything cancels out. Good? Easy? Okay, so now what are you left with? This is 3 to the power 1, which is nothing but 3. That's just 3. Okay, leave it there. Minus, you have a 8 times 6, because 6 to the power 1 is 6. Leave it like that. Again, what do you have here? 15 times 2, 2 to the power 1, because 5 gets cancelled, you are left with 2, so 15.2 plus last one 2 to the power 15. So you got all numbers over here. What are the first things you're going to solve? This is kind of a Bodmer's problem. So this is nothing but it is into over here. You have to solve all the brackets first before doing the plus and minus operation. So what do you get? You get 3 minus 8 6 are 48 plus this sign 15 2s are 30 plus this sign 2 into 15 is again 30. What do you get? 30 plus 30 is 60, 60 plus 3 is 63, 63 minus 48 is how much? It should be 15. That's the answer. Make sense? Is it simple? So the moment you look at a particular problem, you need to remove the noise from the problem. The moment you remove the noise, you can apply the concepts, like how we have applied this particular concept here in this particular problem. Remember that one. If you can do it step by step like this without missing out anything, you'll reach the answer and your answer is going to be correct. You will be confident at the end that you have done everything correct. For example, if you look at this one, if these two are not, if these are not cancelling out, right, means you're in the wrong direction. You need to immediately understand that these are not cancelling out, so I'm not in the right direction. The moment you see that everything is matching, 4 into 1 by 4, 3 into 1 by 3, 5 into 1 by 5, 2 into 1 by 2, means you're in the right direction. And when you're doing this particular Bodmer's thing, remember to do it neatly so that you get the right answer. Okay? Okay. Let's look at one more example, right? They have given this particular expression over here and they have asked you to simplify this particular problem, okay? The moment you look at it, it looks very scary, right? If you look at it, it has all negative powers over here. Then there are fractions involved over here with negative powers over there. And then there is multiplication, there is division. They try to basically confuse you. So don't get confused. Again, as I keep telling you, right? Look at the problem in a very simple way and try to remove the noise. There is a lot of noise over here. The first noise is the negative exponents which are there. So what we need to do is that we need to remove that so that we are able to solve the problem. Okay. So the first rule what I'm going to use over here, if you remember, right? What did we learn? Anything to the negative power, what can I do? I can reverse it. I can basically put it as reciprocal. If you remember this particular logic over here, right? So we are going to do the same thing over here so that we can remove the minuses first. Okay. The first step is I have 81 by 16. What is my A over here? A is 81 by 16. Anything inside the parenthesis is A. And you have a negative power. So can I reverse this one? I can write this simply like this. I can make this as reciprocal 81 and I'm going to make it 3 by 4. I got rid of the negative sign. This is what I'm going to do. Okay, that is the first step which we are going to do. Similarly, for other expressions also we are going to do the same thing. I'm going to use the same this one. I'm going to start a bracket the way it is. Now here it is 25 by 9. So can I make it 9 by 25? 9 by 25 whole to the power 3 by 2. Your exponent becomes positive. Remember always. Divided by, I have a 5 by 2 over here. What I'm going to do? I'm going to make it 2 by 5. 2 by 5, this becomes positive. So the negative noise is cancelled. Now the problem looks much better. Okay. So now what are you going to do it? You are not going to play around with the exponents immediately. First, what I'm going to do is that I'm going to look at the content in the brackets over here. If you look at these two, what are the factors of 16? First and foremost thing in exponents, what you need to do is that you need to make them, you need to find the prime factors of those numbers. So 16, again using the ladder method. 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are. 16 is nothing but it is written as 2 to the power 4. Okay, I got it. Similarly, 81. What can I do with 81? 81 is 327 3 to the power 3 nines are 27, 3 threes are 9, 3 ones are 3. So what do you get? 81 is nothing but it is 3 to the power 4. Can I go ahead and replace those? Right? Let's do that. So now this 16 by 81, I'm going to write it as 2 to the power 4. 16 is replaced by 2 to the power 4 and 81 is replaced by 3 to the power 4. Whole to the power, outside you have a 3 into 4. Leave it like that. Now go to the next one. Next one, start this bracket. What is 9? 9, we know that it is 3 square. Can I replace it with 3 square? I'm replacing 9 as 3 square. Similarly, what is 25? 25 is nothing but it is 5 square. Whole to the power, because we have only simplified 9 by 25 in this particular format. And what do I have outside? I have 3 by 2, right? Go to the next one. Can I do something about this? I cannot do anything. Can I do something about this? I cannot do anything. I'll leave it as is because these are two prime numbers already. So I'll leave it as is. Okay, right? Now look at it. You have a 4 here. So again, can I use that rule? A to the power m whole to the power n is equal to a to the power m into n. Can I use it over here? Yes. So what am I going to do? I'm going to put it as 2 to the power 4 into 3 by 4 in the numerator. This is 3 by 4 in the numerator. This 3 to the power 4 is applicable to this as well. If you look at it, there is a bigger bracket. It is applicable to the numerator also and it is applicable to the denominator also. So I'm going to do it 3 to the power 4, 4 into 3 by 4. Leave it like that for the time being. Go to the next one. Similarly, what can I do over here? I can write this 3 to the power 2 into 3 by 2, right? And in the denominator, it becomes 5 to the power 2 into 3 by 2. Okay, close this, close the bigger bracket. Then you come here, you have what? 2 by 5 whole to the power 3, right? And close the bigger bracket. Now if you look at it, right? All the denominators over here get cancelled out. Right? Now what are you left with? What are you left with? If I may rub this and use this particular space over here, what are you left over here? You are left with 2 to the power 3. So in the numerator, you are left with 2 to the power 3. What are you left with over here? You are left with denominator 3 to the power 3. Right? This multiplication sign put into. What are you left with over here? It's 3 to the power 3. What are you left with over here? It is 5 to the power 3. Into, this is a division sign, not an into. Inside the bracket, what are you having over here? It is 2 to the power 3. 2 to the power 3 divided by 5 to the power 3. Now it's looking very simple, right? As per the bottommost rule, which is the one which you're going to solve first? You have to solve the bracket first. Division comes before multiplication. So what I'm going to do? I'm going to put it like this: 2 to the power 3 divided by 3 to the power 3. This into, leave it like this. I'm going to write this term over here: 3 cube by 5 cube. And this, if I convert into a multiplication sign, this will reverse. I hope all of you know this. Right? Now look at it. It looks very simple, right? I have a 2 cube in the numerator. I have a 2 cube in the denominator. That cancels out. I have a 5 cube in the denominator. I have a 5 cube in the numerator. Cancels out. I have a 3 cube. I have a 3 cube. That is nothing but 1 by 1. Your answer is 1. So the moment you reach this particular stage, you're pretty sure that your answer is correct. You have done nothing wrong. Anywhere you see that there will be a little bit of a different kind of, it may happen that you might get something else than 1, but this is the time where you're going to get to know that my approach is all correct. This is a key where it cancels out with the denominator and it only, you're left with a numerator as a power. So remember this step. Okay, this is one more example. I'm going to basically try out more examples, but what I want to request you guys is to basically put questions in the comments if you want to basically look at solutions for some complex problems. I'll help you out with those. Okay, so this is what we have. I wanted to go through indices and exponents, and as and when you keep putting more questions over there, if I find some challenging questions which I come across, I'm going to solve it for you. So for the time being, just let me know how did you like the video, and I would request you all to basically subscribe to my channel and like. If you like the content, right, just hit the like button. Okay, and share it with all your friends, everybody. So the thing is that everybody should be able to learn maths in a much more simpler way. That is what my intent is, and that's why I'm making these videos for everybody. Okay, thank you very much.